Hello, this is the intro video to Decimology, and a quick definition of what Decimology is, if you don't know already, is it's basically a math of studying the patterns found in all math problems, whether it's algebraic or non-algebraic patterns, geometric patterns. I'll give examples of algebraic and non-algebraic patterns in this video if you keep watching, but the purpose of Decimology is to figure out patterns in math and to better understand the math world, along with using these patterns to help computers compute numbers and stuff quicker, and even doing math in your head. You'll get fast at that, and there's all sorts of stuff to be learned. This is a new field, still growing, so if you want, you can head on over to decimology.com and join the forums. Be a founding father of the math field, of this math field. And also Decimology, it's really when we figure out these patterns, it helps us do all sorts of stuff. You can do stuff in your head. Like I can do a lot of high number division and multiplication in my head now because of these patterns. And also just helping solve mysteries about math we didn't know before. For example, the prime numbers. They're very mysterious. And there's lots of methods now that I've discovered with Decimology that help test the primality of a number and whatnot. So let me go ahead and get started with some examples. First off, I'll give you an algebraic pattern. This is a real simple one. You can do this in your head, impress your friends and whatnot. So this one is multiplying numbers by 11, multiplying integers. All right, this symbol means all real integers times 11. You'll have to excuse my handwriting. I just bought a pad to write on. I'm still getting used to it, but anyways, this is an algebraic pattern. It can be proved with algebra, and it's very simple to prove with algebra. And later on, I'm going to show you a non-algebraic pattern. So without further ado, let's get started on this. Let's say I have a number 62, and I want to multiply that by 11. Well, here's how I'd figure out the answer. And this is a lot easier to describe if you know the notation. There's a lot of notation for Decimology that we had to invent, of course, and those are all also on decimology.com. Or at least they will be soon if I haven't uploaded them already. But I'll try and explain this without the notation if you don't already know. So the way we're going to solve this, and you can do it in your head, is first off you're going to write out 3 digits. Since it's a 2-digit number times 11, we're writing out a 3-digit answer. So 1, 2, and this is how I notate digit places. Inside each of these is 1 digit. Alright, inside the first one, we just put the first number. So there's a 6 right here. So we put a 6 over here. And then in the last one, there's a 2 here. So we put a 2 right here. And to figure out this middle number, it's very simple. You simply take this number and you add them together. So 6 plus 2 equals 8. So let's just go ahead and stick that right there. 62 times 11 equals 682. See where I got the 8 from. And let's check that out on this calculator here. 62 times 11, 682. Let me do another example. 43 times 11. Well, it's going to be 4 something 3, and 4 plus 3 is 7, so it's 473. Just stick the 7 in between the 4 and the 3, so 473. All right, 64. That's a hard. I'll come back to that one. 24 times 11, 264. 2 plus 4 is 6. So you can start doing stuff like that in your head really fast now. Let me explain higher digit when you're multiplying by 11 with higher digits. Let's say I used I don't know, 75 times 11. All right, we know the answer is going to be 3 digits. Let me write those out. All right, the first one's going to be a 7. Next one, a 5. And 7 plus 5 is 12. Now, the problem here is you can't have a number greater than 9 in a digit place, because I couldn't say 712d5. I'd have to say, this would be 7,125, but this is 3 digits, and 7,125 is 4-digit number. So you have to carry over the tens place here. So we're going to get rid of this 1 and carry it over to this. So 7 plus 1 becomes 8. Sorry for the sloppy handwriting. 825. And let's go check that. 75 times 11, 825. Cool. So that's an algebraic pattern, and you can figure out why this works if you simply look at how multiplying by 11 is the same as multiplying by 1 and then multiplying by 10 and adding those two together. And that's pretty simple, but it's still neat to do in your head. So that would be one of the things we focus on in decimology, is improving human head math. Another thing is non-algebraic patterns, and then we also have geometric patterns, but I don't have enough time for all those in this video, so I'll just go over the non-algebraic pattern. This is a very important pattern in decimology. This is the one that started it all. I noticed this probably a year ago, and it's really fascinating. It's with dividing by 9. So if you take, it doesn't even have to be an integer. We can just take any real number. Let's see, this is the symbol for all real numbers, and divide it by 9. And we will get the answer using we'll do it in our head. And just a quick example, I'll just type one up and show you how fast you can do it in your head. Let's say just random numbers. I'll just 123 divided by 9. And I say the answer is going to be 13.6 bard. 13.6 bard. And then if I say something like 47 divided by 9, then the answer will be 5.2 bard. And it's 5.2 bard. So that's just a quick example of how well these methods work, whether they're algebraic or non-algebraic. You can do it in your head. So let me go ahead and show you the pattern. I'll do the first one I used, 123. Oh, whoops. Let's see. 123 divided by 9. Alright, and here's all you have to do. It's very simple. You simply just take the first number and add you take the current number you're with and add all the previous numbers. So 123 is the same as 0, 0, 0, 123. 0, 0, 0. You know, those are the same number. We just don't write out the zeros, but they're there. So we're going to start with our first number, and we're going to add all the previous numbers. So 1 plus the previous numbers. Well, there are none. There are zeros. So 1 plus 0 plus 0 plus 0, and infinite zeros this way, right? So bar on that side. We'll put a bar on this side. So 1 plus infinite amount of zeros is still 1, right? So that'll be our first digit, 1. And then 2 plus 1 plus 0 plus 0 plus 0. Well, we can ignore these zeros. So just 2 plus 1 is 3. So that's our next digit. And then 3 plus 2 plus 1. Well, 3 plus 2 is 5. Plus 1 is 6. So our next digit will be 6. And then we're on 0. So 0 plus 3 plus 2 plus 1 is also 6. And as you can see, since we have an infinite number of zeros going this way, we're going to have an infinite number of Since we have an infinite number of zeros going that way, we'll have an infinite number of 6s over here, so we'll just put a bar over that 6. And now to figure out where the decimal place goes, you just take one less than the number you have here. So example, 123 is a 3-digit number, so the answer is going to be a 2-digit number and then a decimal place. So 1, 2, there's our decimal place. So 123 over 9 equals 13.6 bard. Let's check that. 123 divided by 9, 13.6 bard. Cool. And the same thing applies to this rule as did the times 11 rule. If you end up with let me erase all this real quick. If you end up with, let's say, you have like 7, 12, 15, and there's a bunch of 15s. You can't have 2-digit numbers in a single-digit slot, so you got to carry them over. So we'll carry over this one, so get rid of that one. So there's just a 5 here, and we add it on to this. So 15 becomes 15 plus 1, so that becomes 16. Then we have to carry over this one, add it on here. So 12 plus 1 is 13. And then we have to get rid of this one and add it onto this. So 7 plus 1 is 8. So we have 83.6. And this says it's a 5, but if you add the next 15, since this is barred, you have to carry over that one, so this becomes a 6. And then the next 15, you have to carry over that one, so this becomes a 6. So it's really 83.6 barred. One thing to keep in mind when you're using this divide by 11 non-algebraic, or divide by 9 non-algebraic pattern is that these are the same thing. If I say 0.9 barred, that's the same thing as saying 1. So with that in mind, if I were to say something like 18 divided by 9 using this pattern. Let's see, 18, where am I writing? 18 over 9. Then I would get, well, the first digit's 1, so 1, and then 8 plus 1. 8 plus 1 is 9, and then 0 plus 8 plus 1 is 9. 0 plus 0 plus 8 plus 1 is 9 again, so 1.9 barred. But we all know that 18 divided by 9 is 2, and that's simply because 0.9 barred is 1. So if you're ever doing this in your head and you get something like x, let's say you have a digit x 0.9 barred, that's the same as just x plus 1. So we have 1.9 barred, so that's the same as 1 plus 1, which is 2. And I'm sure most of you know this, but if you didn't know why 0.9 is the same as 1, a quick demonstration. It's because it asymptotes when you go out an infinite number of digits. It asymptotes to infinity, and it adds up 1, but because they all carry over. But a quick example of why that works, if you ever need to explain this to someone, we can just say like 3 over 3. Well, we know 3 over 3 equals 1, right? Now let's say 1 over 3. That's 0.3 barred. Okay? If we take 3 times this, I can just make that 3/3, which is 1. But if I take 3 times this side, instead of doing the fraction, I take 3 times the decimal form, then it would be 0.3333, and then 3 times that. And of course, this would become 0, because 0 times 3 is 3. 3 times 3 is 9. 9 barred. So 0.99999 barred equals 3/3 equals 1. So that's why 1 equals 0.9 barred. Alright, well anyways, I hope you'll head on over to Decimology.com. It's a great new thing we're starting. The forums just opened up today, and I probably won't even upload this video for a while, so you're probably not, if you're watching this right now, it's probably like sometime in July, even though I'm recording this June 27th. But the forums just opened up, and we'd love for new people to come along and share your patterns and tell us new things you find out and help us grow this math field into something great. So go ahead and visit Decimology.com. We have tons of videos up there if you want to learn more patterns and do head math. And if you have any questions, feel free to email me at albertiPhonedeveloper@yahoo.com. I'm more than happy to answer. Also, if you know a pattern, I mean, you can just head on over to the website and post it on the forums if you want. But if you don't want to go over to the forums, you can email me your pattern, and if it's cool, I'll make a video about it. So thanks for watching, guys. I hope you have a wonderful day.